Alright, so what I've built is this over here. Now inside that box is a Teensy 3.6, a relay, and some wires. Not much actually. Alright, but at the end of one of those cables there's a little sort of tan coloured Ethernet cable. What I've used is that as just a extension cable, and I've been able to build this. Now inside that is a light dependent resistor, so nothing fancy. Alright, so what that does is every time there's a LED flash, it sort of goes high, and I'm able to catch it, record it. Alright, and then based on that I can time a test. Now all these meters are connected together. It does look like a bit of a chaotic mess, but it is actually working. Alright, so over here is an Radian RD31. That's a reference watt hour and var hour meter, and that's what I'm here to calibrate. Well, I'm not calibrating it, I'm calibrating these meters in the yellow cases just here. Now these are no different to what you'd see on an industrial installation. These are Mark 6E EMI meters, so these are pretty good. Alright, the red one is a class 0.2 and the silver is class 0.5. Now current is all in series and the volts are all in parallel. So what actually happens is when this is turned on, I catch a pulse from that meter over there, the silver one. I close my relay in. The relay is actually putting volts across terminals in here. Now when those volts are on those terminals, that meter itself starts calibrating itself. It's got a calibration register, and it starts recording energy in those. So I can, at the end of the test, I can actually read them back. So the whole idea is I don't want to take the RD31 out to the field because it's very expensive and it's quite fragile, but these things are a tiny fraction of the cost of one of those. So I want to be able to use this class 0.2 to check these class 0.5s in the field. So if I do the class 0.2 all the time, I'm going to get a lot of history on them. So, and I already have, of the errors on them. So the whole idea is I want to build a cheaper system to be able to calibrate in the field. Alright, so using the Arduino that I've built, what happens is I catch the first pulse, close the relay, puts volts on here, and then starts counting the pulses coming out of here. At the end of the amount of pulses that I've required from the meter under test, it will stop. It'll open that relay, stops this one recording, and then stops counting the pulses from the RD31. So you're thinking, why do I have two units? It's just so I can actually calibrate the system as well as the field devices in this case. So being able to calibrate these two against each other and then these two against each other allows me to remove one from the system. So I don't necessarily need to take this one. That's only for the calibration of the system. Alright, so that's the idea of how that one works. Alright, so over here I've got a Omicron CMC 156. Now that is going to, put the power and the volt, make the power for the circuit. So it gives me current and volts independently of each other, and I can set different angles and different currents and different voltages if I wish. Alright, now to go along with it, I have some software. Alright, so this is the software that I've started developing. I wrote all this. Alright, so the whole idea is you set up your COM ports, which the stuff's connected to. So the pulse counter is connected to one COM port, and the read head is connected to the other. So what I want to do is be able to talk to all the units except the unit under test, because the whole idea is I might not necessarily have access to the unit under test. So as long as I know the pulse output, like what the setting is, I could even work it out, but as long as I know what the pulse output is, I can just run with that. That's the whole idea of using the pulses. Then I'll run the test, and then once it goes, I get the results come up in here, and it saves to a text file which can be imported into Excel. So I'll pause the video, I will run the test and I'll show you the results. Alright, so you can see the errors. So that's the error from the EDMI reference, and that's the error from the Radian reference. Alright, so I can actually change all the angles on the external PC and then do that test again, but I won't. What I'll show you is the tests that I've been doing the last couple of days. So you can see the errors that I've been doing. Now this is the errors that I've come up with. Now the O2 is the error that I've got after I've taken out all the measurement, all the standard errors. Okay, and the O1 is the manufacturer's results. So you know I'm an O1 within, but I still haven't finished. So I'm gonna tighten it up a bit, make the timing a bit better, play around with different settings that I can, and now see if I can achieve the same as the manufacturers. But bear in mind, you don't know where that O1 is, so that could be an O14 rounded down. Consider subscribing if you find this interesting, and see what else I do.